So now we ask ourselves, okay, so if that was flat, what symbol describes curvature? So on a piece of paper, you might think to yourself, okay, what can we write here? Should we write the Christoffel symbols, curvature? Should we write the stress energy tensor? Should we write the metric tensor? Or should we write the Ricci tensor? So which one of these describes curvature? And if you got R correct, then that's pretty awesome. So R is how we represent curvature. And so I'm trying to see where my cursor is kind of gone. So we have R, which represents curvature, and we can set that equal to R lambda, and then mu lambda v, and so now we actually say, okay, so what is lambda? So this is kind of like a shorthand way of writing all of this out. Okay, so we're going to contract all this stuff into that Ricci tensor. And here we have r to the power of t, r to the power of x. These superscripts are basically the four paths that we can take, but we're going to be changing the derivative in this direction. So like the rate at which time changes, the curvature in space of x and the curvature in that direction. So we're going to kind of be changing differentials in that direction. And then, of course, we're going to be considering the two ingredients. We consider time and space here. And those are kind of one way that we can represent this. We're basically carrying through this dimension, looking at how time changes in the direction of time here, using the ingredients of time and space. And here we're taking the path of the x direction. We're seeing how these ingredients of time and space affect that. And so we're sort of going down each dimension and seeing how these two ingredients affect curvature in that direction. So that's what we're doing when we contract this all together.